Alright, so this tutorial is to help a little bit with the laws of exponents, and specifically in this case it's going to be dealing with the laws of exponents that deal with like bases when we're multiplying or like bases when we're dividing. So I'll try to keep it real short here, but we'll cover a couple of things. The first thing I want to just mention real quick is as I ask the question, what does an exponent represent? If I have something like x to the third, or if I have something like 2 to the fourth, what does that exponent actually mean? Well, the exponent itself means I have three x's that need to be multiplied, and instead of writing x times x times x, it's a little more convenient to write this notation of x to the third. So it's a simpler way of writing this little expression right here. And in the same case, if I have 2 to the fourth, that means that I have 4 2's that need to be multiplied. And again, instead of writing 2 times 2 times 2 times 2, it's much easier to write the notation 2 to the fourth, which means the same thing. So in both cases, they're just a little bit simpler version of what's underneath them. Now, what we want to look at is a situation where we may be asked to simplify, and we're given something like x to the third times x to the fourth. And one of the first laws of exponents says that if we have x to the a power multiplied by x to the b power, the law of exponents says as long as the bases are the same, and bases being the x's in this case, we keep the base the same and we add the exponent. So in this case it would be x to the a plus b. So if that's the case right here, our answer would be x to the 3 plus 4, which we could certainly simplify and write as x to the 7th. Now I think it's really important though that we remember why x to the 7th is the correct answer. If we go back to what I asked to start this little tutorial out, what does x to the third represent? It's really x times x times x. And x to the fourth represents x times x times x times x. And in there we really have 7 x's that need to be multiplied, and this is the notation that would make that a lot simpler. So that's the reason we did what we did there. We'll take the next example here, and we're going to go negative 3 to the 5th power multiplied by negative 3 to the 7th power. So if we're going to simplify that, again, hopefully you look at this, and when we talk about bases, we're talking about this part right down here. These bases are the same. We keep the bases the same in this case, and we will simply say, well, let's take it and add our exponents of 5 plus 7, and it would give us negative 3 to the 12th power. Very important that if we're dealing with negatives and the negative is part of it and it's in parentheses, we need to make sure that our final answer is also in parentheses. Next up, we're going to go with y to the negative 4 multiplied by y to the 9th. Just want to deal with this same rule and the fact that we might have a negative in there as one of the exponents. And in this case, we'll keep the common base of y, and we'll take negative 4 and we will add 5 to it, which should give us y to the first power. It's up to you whether you want to write the one. We could certainly simply write that as y. If there's no power written, it's assumed to be a 1, so either of those would be okay in this case. I also would like to take something like x to the 7th power multiplied by x to the negative 10. And the reason being in this case, if I were to add those exponents, I would take the 7 and I would add a negative 10. That's going to be 7 subtract 10, or x to the minus 3. And that's a great answer, but might not be the answer that you're supposed to give. Maybe you're supposed to give this with a positive exponent. Hopefully, we remember from our work with negative exponents that this means send that x to the bottom. Instead of being x to the minus 3, it's going to be x to the positive 3 in the denominator, and it would be 1 over that. So either of those would be equivalent answers. The bottom line is when it comes to multiplying with like bases, we're simply going to add the exponents. So let's now look at, what about if we're asked to simplify, and the problem is x to the 7th over x to the 2nd. Well, the law that goes with this one says that if we have x to the a divided by x to the b, the answer is x to the a subtract b. So in this case, we're going to subtract exponents. In our case, it would be x to the 7 subtract 2, which is equivalent to x to the fifth power, which would be the answer. I should mention again, we just look at why this is the case. X to the seventh, and I'll have to get them all in here, is X. 7 x's that are strung out being multiplied. X squared is 2 of them, and we should now be able to cancel an x with an x, cancel an x with an x, and if you notice we're left with 5 x's, which is the reason the answer is x to the fifth. We'll take another problem, and in this case we'll go with x to the eighth divided by x to the second. X to the eighth divided by x to the second, we'll keep the common base. 8 subtract 2 gives us a final answer of x to the sixth power. Last problem in this little set will be x to the second divided by x to the 11th. And again, we'll follow the same rule. As long as those bases are the same and we are dividing, we're going to say that our answer will be x to the 2 minus 11, which is x to the negative 9. That certainly is correct, but again, remember that isn't always the answer choice you're given, or maybe a teacher wants the answer written with a positive exponent. And if that's the case, a negative exponent means send it to the denominator, and we'll make it x to the positive 9, and we'll have 1 over that as far as the answer. So hopefully from this tutorial you've really picked up here that if we are multiplying and we have like bases, we want to add the exponents. If we are dividing and we have like bases, we want to subtract the exponents in order to get the correct answers. If you don't understand, be sure to ask a teacher for a little bit of extra help. Thank you.